Okay, by the way, in Algebra 2B, we are doing sequences. That's what you're doing now. Okay, look at this sequence over here. What is the next term in this sequence? Even Algebra 2B figured this one out. Alright, let's write it on this list. Try, sit down. No. Yeah. No, he knows it, that's why. Okay, I'm going to write it on this side of the board so we can get it on film. Of course, math team people better know this one.
Wait, what's this one?
Is this?
You start with a 1. How many did I write over there? Okay, good enough. Okay, but how do you figure out this? This is the kind you gotta think out of the box. The kind that we're doing now is just in the box thinking. This is out of the box thinking. And Chai, do you know the math meet is this Saturday? Okay, so the marathon is this Thursday.
Marathon?
Yeah, we get worksheets. Marathon on Thursday? Because Friday is the fair. Obviously, you didn't look at the calendar again. This is the kind of things we take into consideration when we select captains for next year.
Lead by example,
Anyway, look, here, I'll just tell you. You start with 1, and then we call this a see it and say it sequence. Whatever you see, that's what you write down. See? You see it and you say it. What do you see? I see 1, 1. See? 1, 1. And then now, what do I see here? I see 2 1s. See? 2 1. Okay, what do I see here? I see 1 2 and 1 1. See? 1 2 and 1 1. So whatever you see, you say it. You say, okay, what do I see here? I see 1 1, 1 2, and 2 1s. So what do I see here? I see 3 1s, 2 2s, and 1 1. And you just keep on going. So what do I see here? 1 3, 1 1, 2 2s, and 2 1s. That's how you get the next term. You know, there are lots of sequences where you're going to think out of the box, like this one. We did this one in Algebra 2B today. Okay, what is the next term in this sequence? This is the kind of give you on you guys ever heard of Mensa? It's like a club or organization for super smart people. You have to have a minimum 120 IQ or something like that. So they give you a test. They give you a test to see if, like.
What do they do though?
I don't know.
Just
like yeah, we're smart and you're not.
Special voice.
Like, what is the next number in that sequence? You gotta think out of the box. Don't think numbers.
3.
Don't think of the value. Okay, here, I'll give you a hint. 1, 2, 3, 4.
The letters.
Yeah.
Number of letters.
5. Yeah, so it's the number of letters in the word, right? See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many letters in 11? 6. What do you mean you are close? It's either you get it or you don't, right? Okay, so tomorrow's quiz, you're going to have to compute the limit of a sequence. I'm going to give you a sequence. You've been practicing a while now, right? Except you're playing on the board now. Oh my goodness, yeah.
So I mean, you're gonna give us on like the test ones that don't involve mathematical.
No, I'm not going to give you this kind because there's no sense, right? We're just gonna do regular math time. Okay, here we go. What are we on now? 4? We're 4 now? Okay, so we got the quiz tomorrow and the test on Thursday, and then you got no homework for the whole weekend.
Oh, yes.
Okay, so we start with B1. No! Okay, see, you guys are not in tune yet, that's why I look. Sometimes you gotta rewrite it so that you can't do the problem. Like, what if I made the whole thing under just one radical? Put the 2n in the radical, what are you gonna get? 9n squared plus 1 over 4n squared. Now easy, right? Look, just look at that part. If the degree of the top and the bottom are the same, what's the limit? Okay, you look at the leading coefficients, 9/4, but then you gotta square root it, so 3/2. Woo! Just rewrite it. That's the easiest kind you get when you have a rational function. Just compare the degree of the top and the bottom. Okay, are you starting to classify these now? You don't answer me. I forgot period 3. Why is there so much crinkling today? Okay, don't look at the cosine inverse. Just look at that in the. Just look at the thing in the parentheses. What's the limit of that? If the degree of the bottom is bigger than the... You're supposed to do that at home. If the degree of the bottom is bigger than the top, the limit is 0. So these numbers are getting closer and closer to 0. Therefore, the whole thing is getting closer and closer to cosine inverse 0. Which is 5/2. Right? Cosine of what angle is 0? And it has to be in the range, 5/2, right? Oh my goodness. F. That's very worrisome. Didn't we do this as an example? Go to your room right now. When you have a number to the nth power, what kind of sequence is that? Geometric. I thought this was... And then when you have a geometric, you just have to figure out, is it bigger than 1, between -1 and 1? That's okay, this is review. What, you're going to just stay there until it's charged? Okay, so if this number is bigger than 1, what's the limit? Infinity. If it's between -1 and 1, 0. And if it's smaller than -1, yeah, mean girls. The limit does not exist. So you just gotta know, where does natural log 2 fall? Well, we all know by now natural log 2 is approximately 0.693, right? Because we either did chemistry or I told you like 5 times already, right? 0.693 lies within here, so the limit is 0. Mr. Park, what if I don't know that? Then go home, cook rice already if you don't know that. Look, what's natural log 1 equal to? E to the what power equals 1?
0.
What is natural log E equal to? E to the what power equals E? 1. So natural log 2, because E is 2.7, right? So doesn't natural log 2 have to be somewhere between 0 and 1? Yeah, so therefore it falls there, the limit is 0. Even if you didn't know 0.693. You should be ashamed of yourself. H. Are you serious? I think this is an example of the very first thing. That's okay, don't worry your pretty little head over that. Okay, now, if you absolutely don't know anything, just don't know anything, write out the first few terms and see what happens. Plug in 1, 2, 3, 4. See what you get. Plug in 1, go! Plug in 1. Plug in 2. Plug in 3. Plug in 4. Plug in 5. Plug in 6. The limit does not exist because it's just oscillating back and forth between -1 and 1. So sometimes you got to write out the first few terms. J. Is this April 1st? Okay, let's write out, let's say we don't know anything. We don't know anything. Write out the first few terms. Plug in, this is another one we did this as an example before. Plug in 1. 2. Okay, positive third, negative fourth. Positive fifth, negative 6. Now, even though it's oscillating positive, negative, it's still getting closer and closer to 0. So 0 is the limit. Like I told you before, just because it alternates, that doesn't automatically mean it doesn't exist now, because this one is kind of going like this, right? I mean, if you were to graph. Okay, no! You just look at the graph. Now, if you know what the graph looks like, you just gotta look what happens to the graph as it goes out to the right. Now, come on, how can we not know this graph? Cosecant inverse. What does the graph of cosecant inverse look like? Well, first of all, what? What's the range? Negative pi over 2 to pi over 2. And then here's 1 and negative 1, so it's gonna hump right, hump left. Surely we remember that, right? So therefore, what's the limit as the graph is going up to the right? 0. Yeah, of course, if I draw the graph for you, you're going to get it. This graph got to be in your head. Even in AB, you got to know this. I'm not taking calculus next year. K. We just did K. L. Did we or did we not do this in the last worksheet? Did we or you're on the stand now? You are on the stand. You are on the Did we or did we not do this one? So I just change it to this and all hell breaks loose then. It's the same problem, people. This stays between negative 1 and 1, and the denominator just keeps getting bigger and bigger and bigger. Same thing here. Cosine stays between negative 1 and 1, and the denominator keeps getting bigger and bigger and bigger. So again, it is oscillating, but what? The amplitude is getting smaller because you keep dividing by bigger and bigger numbers. So what? It's 0. If you can do that one, you can do this one. Sine and cosine both stay between negative 1 and 1. And okay, there's several ways of thinking about this. Probably the easiest is to simplify this. Isn't this the same thing as natural log 1 minus natural log n if you use your properties of logarithm?
Yeah.
And what is natural log 1?
0.
0. So this is just negative natural log n. Now, do we know what that graph looks like? We better, n to the n fepple, right? What does the graph of natural log look like? It looks like this. It goes to infinity very slowly, but it does. What does that negative sign in the front do then? It reflects it over the x-axis. So what do you think the limit is? Negative infinity then. And then, of course, the coup de grace, O. Now, when you go to BC Calculus, I took this right out of the calculus book, people. Of course, AB, you're not going to see it next year. But then when you take second semester calculus in college, then you're going to see it again. You have to be able to work with factorials. Just like when we did combinatorics. Remember I told you got to be able to work with factorials because in BC, you do it all the time. So all I can tell you is, you got to simplify this. If you simplify this, the answer will just come out, just like eating oatmeal. How do I simplify this? Well, let's look at the factorials. If you have n factorial on the top and an n plus 1 factorial on the bottom, everything cancels out except n plus 1 on the bottom, right? And for those of you who still unshaky on that, look, what does n factorial mean? It means n times n minus 1 times n minus 2 all the way until you hit 1, right? What is n plus 1 factorial? N plus 1 times, what's the next one? N times n minus 1 times n minus 2 all the way until you hit 1. Look. The only thing left is n plus 1 on the bottom. Come on, but when you go to BC, you just gotta be able to look at it. And then, okay, what else do we have left? Okay, let's just go one step at a time. Oh, what do you do when they have the same base? What do you do with the exponents? This is like 1. You subtract. So what? If you subtract exponents, what are you going to get? N plus 1 to the n on the top and an n to the n on the bottom. And then since they're both to the nth power, can I do this? Can I just make them both to the nth power?
Yes.
Yes. And then, hey, you somebody. Lift and separate. What happens when you lift and separate? What is n over n? Plus 1 over n to a. 1 plus box over n to the n. What's the limit of that? E to the box. So what's the limit? E to the 1, which is just e. Do not do this. Now I keep telling you, oh, the limit of this is 1, and 1 to any power is 1. Yeah, except this power is going to infinity. You cannot treat infinity like a number because it's not a number. That's n. Like if this was this to the 5, 1 to the 5th power is 1, but that thing is going to infinity. You guys get that? You cannot treat infinity like, oh boy. Okay, are we getting the hang of this? So tonight's homework, you got 15 more. Next night homework, 15 more. Well, tomorrow you're going to have to be responsible for it. Okay, number 2 and 4. Hey, we're going to finish early today. Ooh, I see 2b. A1 equal 2. AN equal. This looks like tomorrow's quiz right here. Hint. This problem right here looks like tomorrow's quiz. Right down yonder, people. Okay, write an explicit formula for the following sequence. So what do I need to do to start off with? Just stare at it like what you're doing now. Write out the first few terms. Okay, I'll do the first term too. What's the second term? Yoshina, read it off your paper. 7, very good. Okay, next. Sito. 16. Next term, yep.
25.
Okay, now of course if you get it wrong, this is going to be a fatal error tomorrow because you're not going to see any pattern. You got to make sure you get it right. Look, if you want to find the 4th term, what number do you plug in for n? 4. A sub 4 equal A sub 3 plus 16 minus 3 is 13. So to get the 4th term, you have to add 13 to the 3rd term. 29. Okay, one more. What's the next one? So to get the 5th term, you plug in 5 for n, you're going to get A4 plus 4 times 5 minus 3. 20 minus 3 is 17. So you have to add 17 to the 4th term, which is, you got to carry people. 46. Okay, if you don't write out these numbers, how in the world can you even do this problem? Oh boy. Okay, so it says write the explicit formula. Is it arithmetic?
No.
Is it geometric?
No.
So you gotta use your mathematical prowess. Now, do you want to try breaking it down or do that thing I taught you last week?
Do those steps.
The method of finite differences. Because if you can just break it down, then you have to really do that much work, yeah? But breaking it down takes experience. You gotta like try to break it down every time. It's just like factor by grouping. Remember I told you guys? Instead of doing synthetic division, you can just do factor by grouping all the time. But if you don't practice it, you're not gonna get good at it. So can we just assume we're not gonna break it down? So let's use the method of finite differences. What is that, Mr. Park? You look at the differences. 5, 9, 13, 17, and then 4, 4, 4. Oh, it takes 2 levels to get to this constant difference, which means the formula is going to be second power polynomial. So we know the formula is going to be an squared plus bn plus c. It's going to be quadratic. If it takes 3 levels, it's going to be cubic. Now, I'm probably saving the cubic one for the test, but for tomorrow's quiz, you better be able to do quadratic. So all you got to do is solve 3 equations, 3 variables. If I plug in 1 for n, a plus b plus c, what should you get? You should get the first term, which is 2. If I plug in 2 for n, 4a plus 2b plus c, you should get the second term, which is 7. And then if I plug in 3 for n, 9a plus 3b plus c, that equals to the 3rd term, which is 16. Solve those equations. Pretty sure you're going to do this tomorrow. So, you want me to do it? Okay, I will. Subtract this minus this. 3a plus b equal 5. Now go this minus this. 5a plus b equal 9. Go this minus this. 2a equal 4. A equal 2. Plug it back in there. B equals -1. And then plug it back. Probably this one is the easiest. If a is 2 and b is -1, what is c? C is 1. So therefore, the explicit formula for this sequence is going to be 2n squared minus n plus 1. Now well, of course, now that you see the formula, now you could break it down, right? Like, wait, this is 1 times 1 plus 1. This is 2 times 3 plus 1. This is 3 times 5 plus 1. This is 4 times 7 plus 1. This is 5 times 9 plus 1. That's how you would break it down if you didn't use the method of finite differences. Because look, is there a pattern to these numbers, or are these just random numbers?
Pattern.
Okay, so how do you generate 1, 2, 3, 4?
N.
How do you generate 1, 3, 5, 7?
2n minus 1.
2n minus 1, and then plus 1. Isn't that the same thing as that? That's breaking it down. Yeah.
How do you do that?
I just told you! You gotta have it in your bones, your mathematical prowess. It's just part of you.
So it's like special forces?
No, it's just part of you. You've been working with numbers since you were in the womb. I think. B1 equal 1. Bn equal 3. Bn minus 1. Okay, now. We're gonna see. Period 3. Period 4. Period 6. How many people got this problem? Without just looking at the bottom. Go on. How did you do it then? You gotta explain to me how you did it before I put a 1 there. Chai? What?
Isn't there a geometric series within arithmetic series?
Okay, 0.
Added 1.
0.
Added 1.
Yeah, you don't know. Okay, you guys are killing me. Okay, write the explicit. Okay, now this is on the test. Okay, I'm just telling you right now. I'm gonna teach you how to do it, so make sure you learn it. You're gonna see it 2 more times before the test. Now notice that, what are you doing? You're taking the previous term, multiplying it by something, and then adding or subtracting something from it. That's kind of like the quiz, right? Am I supposed to pass back the quiz? Or I did already. Okay, I'm gonna pass out the quiz. Okay, let's write out the first few terms. I'll do the first one. 1. Next, Nioka.
5.
Next.
5.
What are you, Mari?
5.
Oh, your voice came different. 5. Next. Quinto.
Oh, 14.
Oh, you sounding like what? Chen.
41.
Okay, good enough. Now, is that arithmetic or geometric? No. Can I even use the method of finite differences?
Yeah.
No. You can try using the method of finite difference here. Okay, what's the next one going to be? 122. Okay, you can use the method of finite differences, but you're going to have 1, 3, 9, 27, 81, so forth. Then you look at the differences of those. 2, 6, 18, 54. Look at the differences of those. 4, 12. You guys can't do it, right, because you're going to borrow. Anyway, you can look at the differences, but you're never going to get to a constant difference. You will never. So all that means is that the formula is not going to be polynomial. So you either have to rely on your mathematical prowess or be able to listen to what I'm going to tell you now. This is called linear recursion. This is on the test. That's because, doesn't this formula remind you of a linear function, like y equal mx plus b?
Oh, okay.
So whenever you multiply the previous term by some number, doesn't matter what number it is, and then add or subtract the number to that, this is linear recursion. Okay? So I'm telling you right now, the formula is gonna, since you're since you keep multiplying the previous term by 3, isn't, like if you didn't have the minus 1 there, if you just keep multiplying the previous term by 3, isn't that geometric? Yeah, so what it's going to be a mutation of a geometric sequence. So, since you keep multiplying the previous term by 3, it's going to be 3 to the n, but it's going to get mutated. In other words, the graph gets stretched or shrunk, and then gets translated up or down. It gets mutated. So, it's going to be a mutation of a geometric sequence where the common ratio is just this number right there. You guys get it? Okay, now how do you think I'm going to figure out what A and B are? Just like this problem. How did I figure out what A, B, and C are? Yeah, you plug in numbers. Same thing here. So if I plug in 1 for n, shouldn't you get the first term? If I plug in 2 for n, you should get the second term, and then you just solve those equations. So plug in 1 for n, what do you get? 3a plus b, that's got to equal to the first term, 1. If I plug in 2 for n, 9a plus b, that's got to equal to the second term, which is 2. Solve those two equations, and then you're going to get your formula. So just subtract this minus that. 6a equal 1. A equal 1, 6. Who's going to even think of that? Come up with 1, 6. Kwa? How did you come up with that 1, 6?
I didn't come up with that.
And then once you know this, plug it back into here, 1, 6, so that's a half. What is b? What's 3 times a 6? Half. Subtract it. Oh my gosh. Half. So therefore, the explicit formula is 1/6 times 3 to the n plus a half. Who in the world is going to guess that? Not you. Okay? So you have to recognize this problem as linear recursion, and then you're going to do what I just told you to do here. That's the only way you can do it, people. Now, does that work? Look, let's try. If I plug in 1, do you get this? Oh my.
Yes.
If I plug in 2, do you get this?
Yes.
If I plug in 3, do I get that?
Yes.
If I plug in 4, do I get that? I'm just nodding my head, Mr. Park. Who's that? Zhang? That's boorish.
Mr. Park, so you can't use mathematical prowess for this one?
Well, yeah, but your prowess gotta be up there. Because remember we did the mathematical prowess meter? You guys are down here? In order to just figure it out for this problem, your mathematical prowess better be up there. Some of you still down there. Maybe some of you climbed up a little.
Can we see how to do that?
I just showed you all.
Like mathematical.
No, I'm not. No. Okay, we gotta do number 4, and I gotta pass out the quiz. Well, luckily you guys did pretty good on the quiz, unless you did it, so. It shouldn't be a problem. 4. Right? I told you guys this. Okay, you're gonna have 2 of these on the test, okay? You're gonna have 2 of these. Okay, it's gonna look like this. A1 equal 1. I told you guys this on Friday. Plus box. You have to fill in the box 2 times on Thursday's test. Okay, now what did I tell you guys to do? I told you guys how to do this problem. What do you do? What's the first thing I should do?
Write the first few terms.
Okay, write the first few terms. Plug in 1, 2, 3, 4. Go, Saito. And stop making your voice sound like Kwak. Saito. Positive 1.
7.
Stop making your voice sound like a male. Negative 1, 10. Positive 1, 13. Negative 1. Do you see the pattern here? The denominator is getting bigger by 3. You know how I know? Because that's arithmetic, right? Common difference 3. Okay then, what did I tell you to do, Leon? Timmy, Leon? I told you guys, just do this every single time, and nobody's gonna get hurt. If I don't see this on Thursday, this is a fatal error. -8, 2 times. You're gonna get this problem twice this time. And you better have at least 4 there. You put only 3, you're not going to even see the pattern because the one I'm going to give you is a doozy. Okay, fill in the did you guys at least write that down? Call. 10. No, come on, all 3 of you.
Mentally.
No, this is what they do. This is what they do. We should have the video. Call. 10. Hanaoka.
I'm shaking my head. I'll say yes.
Okay, what is it then? Hanaoka, fill it in. Read it off your paper. Because I told you guys to do this every single time. Negative what?
5 fourths.
Negative 5 fourths. Okay, that's correct.
Negative 5 fourths.
Okay, next no, I'm gonna ask. Next one. Quinto. Read it off your paper. Now, if you don't do this, you cannot do the problem. You cannot. There's no way you can do the problem if you don't write out those numbers. Quinto. Okay, if you don't have it on your paper, then you just gotta do the subtraction in your head.
Okay.
What do I have to add to that to get that? Looks like you gotta make a least common denominator of 28, yeah?
4 plus 7.
I see a pattern. Since the numerator is 1, isn't it just gonna be 7 plus 4
Yeah.
over 28,
Yeah.
which is
Oh,
11 over 28. Okay, now that you got the pattern, Leon Lowry, negative
70.
over,
70.
okay, and then positive Miyaoka
23.
over,
130.
okay, good. See, that's all you gotta do. Now you have to take this pattern and write it inside here. Okay, the first thing you notice, negative, positive, negative, positive. It's alternating. So negative 1 to the n or n plus 1.
And
Now
then-
wait, before you answer, this is a recursive formula. If you plug in 2, you want it to come out negative now. So n plus 1. Because remember, in a recursive formula, you start by plugging in 2 now. Because the first term is already given already. You guys get it? This is a recursive formula. Okay, let's look at the numerators. 5, 11, 17, 23. Is that arithmetic?
Yeah.
Yeah, the common difference is 6. Yeah! So you just write 6n and then you adjust. If you plug in 2, you want to get 5. So if I plug in 2, 6 times 2 is 12. What do I have to do to 12 to get 5?
minus
7. Are we building points? We just keep staring as usual. Okay, now the denominator, that one kind of looks tricky because it's not arithmetic or geometric, but if you just remember how you got those denominators, because those are just the least common denominator, right? So if you just do this, hey, so break it down. This is 1 times 4. What is that? 4 times 7. 7 times 10. 10 times 13. Because that's how you got it, right? By making these common denominators. So it's easy to break down. So how do you generate the numbers 1, 4, 7, 10? Hey, that's arithmetic. What's the common difference? 3. So you write 3n, and then you adjust. If I plug in 2, you want to get 1. So 3 times 2 is 6. What do I have to do to 6 to get 1? Minus 5. Now look at the second numbers. 4, 7, 10, 13. Hey, the common difference is 3 again. So 3n, and then adjust. If I plug in 2, you want to get 4. So 3 times 2 is 6. What do I have to do to 6 to get 4? Minus 2. Pakui! Ouch. So this would be about the level of the one you're going to get on the test, but maybe a little tougher. You know why? It's because why do I want to make it all arithmetic? I want to put some flair in there, right?
Lemon twist.
No, not lemony twist. Okay, let me pass back your quiz. We only got a few minutes. Woo! Yeah! Live action.